In this lesson, we're going to continue looking at logarithmic functions as inverses of exponential functions, but we're really going to start graphing them. So you'll see our learning targets is I can graph the logarithmic function as an inverse function, and also I can explain how to graph an inverse function. Okay, so first let's look at, again, we talked in our last lesson about what a logarithmic function is. So a logarithmic function is the inverse of an exponential function. So this graph shows me y equals 10 to the x, and that's my exponential function, and y equals log of x. Remember, if I don't have any base down here, I know that it's going to be a 10. So note that 0, 1 and 1, 10 lie on the graph of my exponential function, and that 1, 0 and 10, 1 lie on the graph of my log function, right? And that tells me that they're inverses. So remember that the graph of a function is symmetric over the line y equals x, right? So I have my line, and if I were to fold this graph over that line, these two inverse functions would line up exactly. So we know that they're inverses. So that's another way we can graph them. Okay, so here we go. We're going to be graphing some functions. So I'm told to graph y equals log base 2 of x. So by my definition, the inverse is y equals 2 to the x. So I can graph that function, right? This is the one that the parent function that we looked at in our last couple of lessons and then did some transformations. We looked at a lot of y equals 2 to the x. So I can pick some points, right, and plot them and graph my function. And then I draw my line y equals x, and I can find the distance from those points to the line and reverse the coordinates and plot those points. So you see here a couple of points that I found on my exponential function. I found negative 1.5. So you'll see this point, I just reverse the order of the points, and that will give me my new point on my logarithmic function. So same here. I had a coordinate point at 2, 4, so I will switch the order of those values and have a point at 4, 2. Okay, so here's something you really want to keep track of is what happens to our log functions, right? Because we're talking about our parent function of log base b of x, where b is going to be greater than 0 and b cannot equal 1. Okay, so if I, again, have a stretch, right, I use my a value, and that a value, just like all of our other families of functions, goes in front. That tells me I vertically stretch it. Again, if my a value is negative, it reflects it across my x-axis. So these are the same transformations that we've looked at with our other families of functions. So if I have a horizontal translation, right, here's my x minus h. Same thing, remember that this is a minus in here, so it's a little backwards. And then my vertical stretch is k. It's out here, not in the parentheses, not with anything else. So the transformations that we've learned before still work with logarithmic functions. So here we go, we're going to actually translate a function. So I'm asked to graph this big function. So first I want to find the parent function, which is log base 6 of x. And then I can plug in some values and solve for my y. That gives me some points to plot. So then I know that this 2 right here shifts it to the right 2 units, and this 3 shifts it up 3 units. So I take these points that I have plotted and shift them to the right 2 and up 3, and I get my new graph for my new function. So now I want you to go ahead and graph log base 3 of x plus 3. And the question for this one that you're going to answer is, what happens to my function? Like, what are the transformations that I do to this function? Okay, so here's the rest of your homework for this section. Make sure that you check your calendar, and let's just go double check our learning targets. So our learning targets, I can graph the logarithmic function as an inverse, and I can explain how to graph an inverse function. Just remember, the big thing about inverse functions is I have my coordinate plane, and I have that line y equals x, and my graph is reflected over this line, gives me an inverse function graph.